given that 2 log base 3 of x minus 5 minus log base 3 of 2x minus 13 is equal to 1, I want to show that x squared minus 16x plus 64 is equal to 0. So I'm first going to use laws of logarithms to combine these logs together so that I can have a single logarithm, so that I can then do the inverse of logarithms to get rid of it and just leave me with a polynomial. So the first thing I need to do is deal with that coefficient of 2. So I'm going to take that 2 and put it as a power. Excuse me. So that's my first step. My second step is I'm going to use the subtraction law. So I'll have log base 3 of x minus 5 all squared over 2x minus 13 is equal to 1. Excuse me. Right, I've now got the logarithm by itself, which is good because it means I can do the inverse of a logarithm to get rid of it. The inverse of log base 3 is 3 to the power. So if I did 3 to the power on the left-hand side and 3 to the power on the right-hand side, that's going to cancel the logarithm out and just leave me with x minus 5 all squared over 2x minus 13. On the right-hand side, I've just got 3 to the power 1, which is 3. I've now managed to get rid of the logarithms, so I can now multiply both sides by the 2x minus 13. Expand the brackets and move everything over onto one side of this equation. And that is what I wanted to show. So that's part A done. Part B, hence or otherwise, solve this equation. Well, hence, I just showed that this equation is the same as this equation. So I could just solve this, because they're the same equation. So let's factorise this equation. I get x minus 8 times x minus 8 equals 0. So this is actually a perfect square. And I get one answer, which is x equals 8. That is one repeated solution to this quadratic equation. And I should just double check that that works with the logarithms, because I know I can't do log of a negative number. So if I substituted 8 in here and here, would either of those things be negative? No, it wouldn't. 8 minus 5 is 3, so that's fine. And then 2 times 8 minus 13, that's 3 as well, so that's not going to be negative. So this is a good solution.